All right, we have a very important question before us now. Welcome back to another great section of this lovely tutorial class. I'm super excited to see you guys back to class, and you all know that this class is a blessing to this generation. So what you need to do now is to ensure you just like this video, share it to others, and ensure you don't distract yourself by any means. Now, the question actually is, what's the number of molecules, not amount of substance or numbers of moles? You can see two answers, they have the same value but different units. Now, numbers of molecules is always in molecules, which is numbers of particles. I can ask you what is numbers of particles in 10 grams of methane, or what is numbers of molecules in 10 grams of methane. So the unit should be in molecules. That's the first thing you should take note of. So, now, how do we solve this question? That's the major thing again. How do we solve this question? So let's go. Let's go. All right. The question is numbers of molecules. Remember I told you guys that numbers of molecules is actually different from numbers of moles. Amount of moles is amount of substance we are talking about. The number of molecules have to do with the number of entities of particles. So what we are asking for now is, what is the number of molecules in 10 grams? In 10 grams of methane. In 10 grams of methane. So the numbers of molecules here. So we have so numbers of molecules. So what is the numbers of molecules in 10 grams of what? Of methane. So that is the question in this place now. So what I'm going to do? Remember I told you guys that. Let's just derive a formula. A very nice one, that we collate all these things together. So remember I told you, let's start from here. Numbers of what? Amount of substance is equal to what? Numbers of particles divided by what? Avogadro's number. I also said amount of substance is what? Mass over what? Molar mass. So if we decide to, since n is equal to n, if I decide to equate these two now, what am I going to have? I'm going to have something like this. Numbers of particles over Avogadro's number will be equal to this other one, which is what? Mass over what? Molar mass over molar mass. So we are looking for the numbers of particles now. That's what we are looking for. So how many molecules are here? We are looking for numbers of particles. So there are numbers of particles now as a function of mass and molar mass. We want to get the numbers of particles as a function of mass and molar mass, not as a function of numbers of moles. So we're going to apply this to this place. We're going to have Avogadro's number times mass divided by the molar mass. So this is what we are going to use now to solve our problem. This is just change the solid to formula. That's what we are just doing. So from here now we can even get mass as a function of numbers of particles and the rest. So let's use this formula now to solve this problem, to see what we're going to have. So sticking with that formula is very, very important. So let's use that formula now. So we have derived a new formula from these basic formulas. So please take note of that. It's very, very, very important. Take note of that. It's very, very important. So let's go. Let's go to the next now. So our formula now is now numbers of particles what? That is Avogadro's number times mass divided by what? Molar mass. So this is what we are using now. This is what we are using. So please take note of that. It's very, very important. So the first thing is that we know the mass. We know the mass to be Avogadro's number is what? 6.022 times 10 raised by what? That is 23. Then we know the mass from the question. They said is 10 grams of methane. 10 grams of methane. But we don't know the molar mass of methane yet. But we know that methane is what? What is the formula for methane? Molecular formula. Molecular formula of methane is CH4. That's the molecular formula of methane from organic chemistry. So you can still remember that methane is CH4. CH4. So we can get the molar mass of methane from this CH4. You know that C is carbon. C is carbon, which is 14 grams per mole. Then H is hydrogen, which is what? 1. We already carbon 12, not 14. Please take care of that. It's nitrogen that is 14. Carbon is 12. Then nitrogen is 1. Please take care of that too. It's very, very important. Remember, we used carbon before we were doing a glucose, C6H12O6. So we are going to use this now to get our molar mass for what is it called, for glucose. So let's get our molar mass to see what we are going to have here. So let's get our molar mass out. Let's get our molar mass to see what we're going to have. So the molar mass of methane will become CH4. Let me write this out so that you understand it better. C is what? C is 12 plus H is, remember H is what? 1. Therefore remains. So that will give us 12 plus 4. That is 16 grams per mole. That's what we're going to have. So this is the molar mass of methane, 16 grams per mole. Please take note of that. So our amount of, that is the number of molecules now of glucose present there in 10 grams now will be what is the we have Avogadro's number. Remember the formula, which is our Avogadro's number times mass divided by molar mass. So that give us Avogadro's number is 6.022 times 10 power what 22 times the mass, which is 10, divided by the molar mass, which is 16. So if you calculate this, let's see what we are going to have. So if you calculate this, let's see what we are going to have. The answer will becomes, we have 16, that is 6.022 exponential 23. Try and do it with your calculator to see what you are going to have, times 10 divided by 16. So in this place, I'm having let me create a little more space to get the answer out. Create a little more space to get the answer out. So in this place, I'm having something very nice. I'm having the numbers of particles as 3.76 times 10 raised to power 23 molecules. 23 molecules. So this is the number of particles present there. 3.76 times 10 power 23 molecules. So this is how you calculate numbers of molecules or numbers of particles. Thank you.